Welcome to This Explainer. Today, we're unpacking the hidden mechanics behind how our modern products are actually made efficiently by tracing the really fascinating evolution of factory production. Have you ever stopped to wonder how complex machines, cars, or even the electronics sitting on your desk go from raw materials to a finished product in your hands, all without the manufacturer going totally bankrupt in the process? It's this incredibly delicate, high-stakes dance of time, money, and physical space. And at the absolute center of this dance is a powerful concept known as load leveling, which today is driven by the sheer power of advanced production schedulers. To really understand the mechanics of how they do this, we have to start by asking what sounds like an impossible question. So let's dive right into the ultimate question that has basically driven all manufacturing innovation for decades. How do you run a massive factory without wasting a single dollar on inventory? Historically, running a factory was essentially a massive financial gamble. You'd buy literally tons of raw materials, pay hundreds of workers, build thousands of products, shove them all into a giant warehouse, and just cross your fingers, hoping someone would eventually buy them. It tied up millions in cash. But what if there was a way to completely eliminate that risk?
Well, the absolute holy grail of manufacturing is a concept called make-to-order. This is the ideal state where a factory operates with absolutely zero wasted capital. You don't buy a single screw, you don't turn on a single machine, and you definitely don't use a single hour of labor until a customer has placed a firm, guaranteed order. Imagine walking onto a busy, humming factory floor and knowing for a fact that every single item being worked on is already sold. That is the dream. And think about the sheer power of this for a second. If you can get cash up front, you don't even need your own working capital to build the product. A great example of this is Tesla's reservation system. Customers put down a deposit long before their car is ever built. When you operate this way, those prepayments can actually be used to fund the production facilities themselves. It completely flips the script. The only things existing in your factory are materials and labor that have already been matched perfectly to an eager customer's demand.
But historically, getting to that ideal state was pretty messy. After World War II, the global standard was Ford's lot production. You'd make a huge batch of, say, 1,000 parts at step 1, and they just sit there gathering dust, waiting for step 2. It required massive intermediate inventory and staggering amounts of floor space. But Toyota realized this was incredibly wasteful. So they introduced Kanban, a mixed-flow system where the intermediate inventory between steps was slashed down to exactly 1 unit. You only take what you need for the next step exactly when you need it. Nothing sits around waiting. Now, the financial impact of Toyota's mixed-flow method is frankly staggering. It drops the required operating capital to roughly 1/100th of what traditional lot production requires. Just think about that. 1/100th! Imagine running a massive industrial enterprise with just a tiny fraction of the cash you used to need. By keeping capital in high rotation rather than letting it just collect dust as half-finished goods, your efficiency completely skyrockets. You suddenly free up 99% of your capital to invest back into the business, into research, or into expansion.
And because you aren't waiting to finish 1,000 units before moving to the next step, your cash isn't held hostage in half-finished products. Lead time, which is basically the total time it takes from buying your raw steel and plastic to actually collecting cash from the customer, is dramatically reduced. In the old lot system, your self-funded capital could be trapped on the factory floor for months. In a mixed-flow system, turning raw material into cash is just a matter of days, or in some highly optimized plants, literally hours.
But wait, beyond just cash, there's a third massive benefit here: the sheer physical footprint. Because you aren't storing thousands of intermediate parts between every single machine, the factory floor gets incredibly compact. Historically, this freed up an unimaginable amount of indirect capital. You need significantly less land, smaller buildings, no heavy overhead cranes, and zero fleets of forklifts buzzing around trying to move piles of inventory. Fun fact, these exact spatial and financial savings were actually a huge driver of Japan's post-war industrial boom. So you're probably thinking, wow, mixed-flow production sounds perfect. But is it? Well, just when you think the mixed-flow system solved everything, a hidden villain sneaks right onto the conveyor belt. You see, as this system spread globally, manufacturers started mixing completely different types of products on the exact same line to meet diverse customer demands. You weren't just building the identical black Model T anymore, you were building sedans, trucks, and hybrids back to back. And that's when a major logistical headache reared its head. Enter the theory of constraints. Basically, if one highly complex car model takes longer to build, every single station behind it has to stop and wait. Imagine a conveyor belt building a standard car. And then suddenly, a highly customized luxury model comes down the line. It requires extra wiring, premium leather, fancy computer modules, you name it. The worker at that station takes twice as long. Because it's a flowing, continuous line, everyone else is now held up by that single bottleneck. The entire factory's pace immediately slams the brakes to match the slowest denominator.
So how on earth do you manage thousands of customized orders without your factory just grinding to a complete halt? Well, the hero of this story isn't actually a new machine or a faster robot. It's a highly specialized piece of software, the production scheduler. This software is designed specifically for complex engineering environments, and its entire reason for existing is to perfectly level the load across the factory. This is the exact mechanism that keeps modern production flowing. It acts as the invisible brain, ensuring the line never, ever stops.
Let's look at how this algorithm takes total chaos and reorganizes it into a perfectly leveled flow, a process known as Heijinka. Before a single machine even powers on, the scheduler simulates the entire production plan. It uses that theory of constraints to hunt down exactly where the bottlenecks will pop up before they occur in the real world. Then, it strategically shuffles the sequence of products, maybe slotting 3 simple, standard cars immediately after one highly complex luxury car, to perfectly balance the workload. It mathematically levels the load across the whole factory, so peak performance is constantly maintained with zero human guesswork.
Okay, so production schedulers perfected the conveyor belt line, but manufacturing engineers were already asking the next big question. What if we just left the conveyor belt behind entirely? Software totally fixed the scheduling of the line, but engineers wanted the next major physical leap in efficiency to completely eliminate those tricky variations in assembly time once and for all. Which brings us to cell production, famously known in Japan as yatai. By consolidating all assembly steps to one single person, you slash your working space to 1/10 and eliminate the timing gaps between different workers entirely. Instead of a car moving down a line of 50 different people, one highly skilled worker stands in a specialized, compact cell and builds the entire product from start to finish. There are absolutely no bottlenecks to worry about because there is no line to slow down. The capital efficiency of this method can literally be thousands of times higher than the old lot production. But yeah, there is a massive catch. Training someone for years to build 40 different complex machines is incredibly tough. I mean, in industries like construction machinery, expecting one human to memorize the entire assembly sequence for dozens of distinct models, each with thousands of parts, is a monumental ask. The traditional cell system requires literal years of apprenticeship to truly master. And that brings us to the ultimate modern solution, the digital yatai. Digital technology bridges this human skill gap almost instantly. The digital yatai equips that single workstation with smart screens, audio instructions, and network-connected tools. It guides the operator step by step. If they pick up the wrong screw, or maybe they don't tighten a bolt with enough torque, the system detects it and literally stops them from moving forward. Mistakes are caught before they even happen. Thanks to this setup, what used to take years of intensive training now lets a complete novice become an expert operator in just about 1 week. 1 week. At the end of the day, managing a factory involves massive upfront investments, balancing inventory, predicting sales, and constantly adapting to a changing reality. As this quote hits the nail on the head, rewriting schedules to meet customer demands is grueling work, but production scheduler software can be the savior. Trying to do all this manually is almost impossible. But advanced production schedulers, working hand-in-hand with incredible physical innovations like digital cell production, truly are the definitive saviors here. They give factories the power to perfectly level their loads, adapt instantly, and stay highly profitable. So as we look at just how far we've come, from Ford's massive dusty inventory piles to Toyota's brilliant one-unit mixed flow, to software achieving algorithmic load leveling, and now digital yatai turning pretty much anyone into a master builder in a week, it's clear the factory floor is this incredible, relentless engine of innovation. It makes you wonder, as AI begins to optimize these very production schedules even further, what is artificial intelligence going to revolutionize next on the factory floor? Keep an eye on this space because the evolution of efficiency is only going to accelerate. Thanks for joining me for this explainer.